All right, so we're live. Welcome to the Refactoring Mob. Stella and Sess is with us. And so we're on chapter 8 of the Sandy Metz's Pooter book. Oh, and here is Gideon. So we're just getting started. Gideon, welcome.
Yeah, thank you.
So we're on chapter 8 of these, what is it called? Practical object-oriented design using Ruby. So we did like probably the first half of chapter 8 last time, but we're going to review it since it's been a couple weeks. So let's get started with that. I'll share my screen. And here we go. All right. So chapter 7. So the previous chapters, we've been talking about pretty much keeping our code dry has been the main theme. But, we started with basic fundamentals of object-oriented design, creating classes with single responsibility, managing those dependencies, and how to create a flexible interface. We've talked about duck typing. And then in chapter 6, we built a inheritance model to implement our bicycle class. So here's our bicycle, and everything was working great. We had a bicycle, and then they said, oh, we need a road bike, and we need a mountain bike. So we started building out. So we built another class called road bike, which is a bicycle, right? So naturally, it would inherit from bicycle. Sorry, mountain bike came first. So mountain bike inherits from bicycle. And then we got a road bike. And eventually, so we had this inheritance model here. A road bike is a bicycle, a mountain bike is a bicycle. And so whenever you hear that is a word, you kind of can correspond it with inheritance. So yeah, whenever you talk about objects having an is a relationship, that's could be represented using inheritance. And then so everything's great, and so everything's working great. We went through the refactoring of setting up this inheritance model. And then we got to a point where we're all done, and we're asked the question, where is it? So the question is, like, what if they come back to us and they want to build, well, let's say we got the mountain bike, we got the road bike, and then we got a recumbent bike. What if they come back to us and they want to have a recumbent mountain bike? It's not so easily implemented with the inheritance model, because now you got some specialization of road bike, some specialization of mountain bike. You can do it. You can definitely do it in other languages, but in Ruby, not so easily. And so it just spawned that question on us and said they'll cover the answer in chapter 8, which is the chapter we're on. And chapter 8 is about composition. So now I skipped chapters. Then chapter 7 was all about sharing behavior using modules, which was a really good chapter. But yeah, so chapter 8 is combining objects with composition. And composition is the has-a relationship right here. So you can create software the same way by using object-oriented composition to combine simple, independent objects into larger, more complex wholes. And in composition, the larger object is connected to its parts via a has-a relationship. I'm sure you've heard about has-a, is-a. For me, it's kind of confusing for a while, but whenever you hear is-a, you can think of inheritance, or when you ever hear has a relationship, you can think of composition. So what is composition? They explain it like, Sandy used the analogy of like Mozart's musical or Beethoven's or whatever, a symphony, like a symphony, right? So each sound is an independent sound, and by itself, it's just a sound. But when you combine it with all these other sounds, the music becomes composed. And we can do software the same way. We can, a bicycle has parts, and a part just by itself, doesn't really do much. But when you combine all the parts together, you compose it into something great, which is a bicycle. And this is the UML diagram for the bicycle and and parts. So a bicycle has parts, right? So we we refactored all our inheritance code from chapter 6 to use composition in chapter 8. And unfortunately, let me make this bigger. And if you didn't see, so I've got the link here. I'll paste it again in case it doesn't show for everyone. But here's the link to join the VS Code, and we will do some coding today. So right now, as it stands, we've got this bicycle class. We've got some extra things in here that aren't a part of this chapter, but that were a part of previous chapters, but like lead days. But so we got this bicycle class, and we had a road bike, we had a mountain bike, and we had a recumbent bike class that all inherited from bicycle. And then so what we did through chapter 8 is we refactored it to use composition. So the first thing we did was we converted the existing bicycle class to this new design, which removed most of its code, and we added a parts variable to hold the parts object and delegate spares to parts. So spares basically just asks, what kind of spares does a mechanic need to bring on a road trip for the bicycle? Maybe like a spare inner tube, some tape if it's a road bike for the handlebars. So that's all that spares method is. And if you have any questions while I'm going through this, just stop me. Just ask me at that time. One thing I do want to mention is that, so this diagram right here, so it shows the bicycle and parts class connected by a line. So the line attaches to bicycle with a black diamond, and then this black diamond indicates composition. So if you ever see UML diagrams and you see this black diagram, this is a has-a relationship. So it means that a bicycle is composed of parts. And the parts has a number 1, which means there is just one parts object per bicycle. And then the parts object is going to have many part objects. Like it's going to have an array of part objects that make up all of the bicycle's parts. So here's the parts object after our first refactoring, and then the refactoring took us through. Okay, so now instead of having a mountain bike inherit from bicycle, we moved most of the bicycle code into our parts class. We created a parts class, moved most of the bicycle code into the parts class, and it really made sense to do that, because as we did that, we saw that these really do belong in parts. Default tire size makes more sense in a parts class. asking for spares makes more sense in a parts class, and chain as a part makes more sense to have it in a parts class. So it really made sense to do that after we removed all that code from bicycle into parts. And then we changed, and then all we did for our road bike and our mountain bike class was we renamed it to road bike parts and mountain bike parts, and we inherited from parts instead of bicycle. So now we got, and then so what we ended up with is, instead of a UML or a mountain bike and road bike inherited from bicycle, after our first refactoring, we had a bicycle which has parts, and then we had a mountain bike parts, which is a parts class, and a road bike parts, which is a parts class. And then we checked, everything still works. It was all good. We're not finished there because we want everything to be used with composition. So then composing the parts object. So there's the parts object, and it may contain many part objects. So we have a parts class and a part class. It might sound kind of confusing, but if you read this, she kind of explains her, that theory on why to name it like that. It just makes sense, and you can explain it this way. Thus, we have a parts object, and it may contain many parts objects. So they pluralize objects here, and here they pluralize parts. So it's the main distinction. And then so creating a part. So figure 8.4 shows a new sequence diagram. And so here we get a new sequence diagram. And then, so the sequence diagram, we get bicycle. It can ask parts for spares. And then the parts will just ask each part if it needs a spare. And it can return the answer to bicycle. Then the UML diagram, you can see bicycle has parts, and parts has many part objects. And you can see that by the 1 ... star there. It's more than one. And so now our parts class, so after we did this refactoring and we created a class part, you see there's very little code in our bicycle class. There's very little code in our parts class. And our parts class just has an initialization method, which has the name of a part, description, and then a Boolean saying if it needs a spare or not. And that's it. That is our entire composition. And so the advantage of this over inheritance is that, let's say they needed a recumbent mountain bike. Well, that would require us to go in there and code a class that is a recumbent mountain bike class. But here, using composition, all they need to do is go into all they need to do is create a new part and say, well, for a recumbent mountain bike, I just need a flag and maybe a shock and a chain, and then put those parts together, and they got a recumbent mountain bike. It doesn't require us to code anything, because they can go into their web page and say, create new part. And they just start saying, okay, the name is chain, give it a description, and say whether it needs a spare or not. And then they can take all these different parts and put them to a name saying these are parts for a recumbent mountain bike. And then they can create a bicycle that has parts composed of for a recumbent mountain bike. So now they can create any bicycle object that they can dream up of, and they don't have to give us a call or anything. So this is a much more flexible design than the inheritance model that we had, and the inheritance design that we had. So here we got, so here gives a description, so we can use our new composition design, just saying, okay, let's create a chain object. So we got a chain, and then we create the new part. We can create a new part for road tire, and then a new part for tape, mountain tire, rear shock, front shock, and whatever else you can dream up of. So individual part objects can be grouped together into parts. And then and then here, so now we can create parts for road bike parts. So road bike parts, takes a chain, a road tire, and tape, and that's it. We've got the road bike parts, and once we have the road bike parts, we can create a new bicycle with road bike parts. And then so here we can create a road bike, which instantiates a bicycle, and then we say parts.new, chain, road tire, tape. Those are the road bike parts, and we can ask it for its size. We can ask the road bike for its spares, and now we can even create a recumbent mountain bike if we wanted to, without any issue at all. So that's the main advantage over this design over the previous design with inheritance. So that's where we got to last time with the last session. We ended here on making the parts object more like an array. So let's hop into it. So this is our code. So we can ignore schedulable. It's there, but we're not really focusing on it this chapter. So we got our bicycle class, and we have our spares method here, which just asks the parts object for the spares. And here's our parts class. And it also, and then it has the spares method. So when we ask the parts object for its spares, it just selects, it takes the part, and if the part needs a spare, it only selects those parts and returns them. And then our part class is really simple. It's pretty much only like a data class, right? It just holds these data items: name, description, needs spare. And that's it. And then you can see here we were creating a chain, road tire. It all works. Let's make sure it works. So I do Ruby ch6/bicycle. All right, so it doesn't work. So select wrong number of arguments given 0. I might have been playing around with this code and left it in a broken state. That's bad of me. So line 50, spares method, wrong number of arguments. So it was given 0 and expected 1 to 4 arguments. Does anyone know what's wrong with this? We're calling roadbike.spares, and then they got moved up to line 34. And then the road bike, it calls parts.spares. So road bike.parts.
Nick, I'm a bit lost.
Yeah.
Where you're calling parts.spares.
Okay. Yeah, it is let me do this instead. Let's see. Let's make sure. So yeah, so I think we have to have parts.select. So let's change that there. So yeah, so that works. Because select just didn't know what to select from, so we needed to say select from the list of parts. Does that clear up the confusion, or?
This somewhere I had seen that you had called spares on parts, like, so I assumed that parts are several. Is it possible to call a method or a collection?
Can you clarify that question again? Can you repeat it one more time?
There's a line on the code, I can't recall what it was, but it was
Okay.
parts.spares.
Parts.spares. Okay.
Yeah,
Yeah, right
yeah.
here.
So is it possible to call a method on a collection,
Is it
or what's
possible?
happening there?
Okay. So yeah, so let's walk through this. This is kind of like the same thing as saying self.parts.spares. So yeah, so if I run that, I mean, it's still going to work. So yeah, so it still works even though I put the self in there. What's happening is, so we created a road bike here. So our road bike instantiated a bicycle class. And then the parts is a parts class, which has a chain part, a road tire part, and a tape part. So you can see the road tire here is that right there. It's just a part. These are all part objects. So this chain is a part object. Road tire is a part object. Tape is a part object, and they're in an array here. So they're basically an array. So when they get instantiated in the parts class, the parts class gets that an array, and it just assigns it to @parts instance method. And we have an attribute reader there, parts, and then the select is a method for an array. So the parts dot select, and it's going to iterate through the array and select, and then if this returns true, then it's going to append it to a new array that will be returned. So for each part that needs a spare, then it'll be returned in a new array. And that's what we get here. We get this new array returned back with part objects that needs spare. So here you can see @needs spare is true. So yeah, so when we instantiate the parts class, and that gets instantiated into the bicycle class with the size of L, and the parts is basically that parts object. So when we call bicycle, so when we say road bike dot spares here, that's going to the bicycle class. Boom, boom. So that's going to the bicycle class, calling this method. And then it's saying for the bicycle class parts, self.parts, which is this right here, which is our parts class, it's asking it for its spares. So it goes to the parts class and asks the parts class for its spares. And the parts class is saying, well, I have an array of parts, and just select the part. For each part that needs a spare, just select those and return them. And yeah, that's what's going on there. Does that make sense now? Or
Yeah, thanks.
you're welcome. And we can, I think there, so yeah, so right here, so this is what's happening. So bicycle calls spares, and the parts method receives that spares method. And then for each part in its part array, it asks if it needs a spare. And then it gets the results back, and it returns the results to bicycle. So the parts object, it seems like an array. So all we deal with this array. That's all we deal with the parts object. So the parts object almost seems like an array at first glance. So, but it doesn't have any array-like features though to it, because it's not an array. It's just a parts object. So this is, so it's explaining. So this next section is going to explain what can we do to maybe make it more like an array, and it's going to talk through a few different scenarios that we can use. So yeah, so it says this code works. So as we can see, this code works, and we can create any bicycle that we want using any kind of part. This is good code, and it works. But if we step back for a minute and think about the parts and spares method of bicycle, these messages feel like they ought to return the same sort of thing. Yet the objects that come back don't behave in the same way. So when we ask a bicycle for its spares, we get an array back. Yeah, see, this is an array. We get an array back that has part objects in them, and we can ask its spares for its size. We get size 3, and then if we say, okay, so we can ask a bicycle for its spares, and we can ask the size of the spares. We can also ask the bicycle for its parts, and we get parts back, right? So let's do this. So if we get road bike, and we ask for its parts, and we run this code, we get parts back. However, this is not an array. It is a parts object, obviously, right? So we can ask road bike for its spares.size, and that works. I'm going to put a separate line in here. Yeah, separate it out. Oh, that didn't work. So we get size 3 of back when you ask for its road bike size, but if we ask road bike for its parts and we ask how many parts do you have, we get an error. It says undefined method size for parts. And so it's saying, yeah, so right here we get no method error, undefined method size for parts. So Sandy is making the observation that it seems like they should return the same type of, they should behave the same way, right? When we ask parts for its size, it should return its size. So what are some things we can do about that? Well, we can implement a size method, def.size, and then we just say, and then we just delegate that to parts, which is an array, and arrays respond to size. So, oh, sorry. Sorry, I need a breather. So you can fix the proximate problem by adding a size method to parts. This is a simple matter of implementing a method to delegate size to the actual array, as shown here. So parts, parts basically only deals with an array. That's all we care about is that array. But yet, it doesn't behave like an array. It behaves like a parts class. So I think, so we can implement size and all is good. It responds to size. However, this change starts the parts class down a slippery slope. Do this and it won't be long before you'll want parts to respond to each, and then sort, and then everything else in an array. So your parts class can get really big if you keep doing this, filled with methods that are already designed and implemented in the array class. So this never ends. The more array-like you make parts, the more like an array you'll expect it to be. So then perhaps parts is an array. So there's that keyword is. So that means inheritance, right? So perhaps parts is an array. Albeit one with a bit of extra behavior. So you could make it one. So the next example shows a version of parts class, which is now a subclass of array. So all we do is add this less than symbol and then array, and now parts is an array. And then since it's an array, seems like we just have that definition method spares, and we don't need the parts.select in front of spares anymore, because parts is an array. So the above code is very straightforward. Expression of the idea that parts is a specialization of an array. So let's go ahead and give that a try. Somebody, he's logged in. Sess, do you want to make our parts class an array?
Sure.
All right. Believe it'll be line 42. Yep. Sweet. So parts is an array, and it seems like we can remove, I'm not sure why, but it seems like we can remove this from the select method. So let's give that a try, see if it works. All right, cool. So what's going to be happening here? So let's see if this all works. So now if we run this code, let me remove this. Okay. So we're missing something. So we just get an empty array back when we ask for spares. So array parts. So let's see, in a perfect, okay, it doesn't show the whole change, obviously. I think we still need to have parts here. I think there's probably something we can change to make that go away. I'm not quite sure what it is off the top of my head, but it's working. So parts is an array, and now we can ask, can we ask the road bike for its size? So parts.size, does that work? That returns 0. Yeah, so it doesn't show all the code. So maybe what I do think it's doing though is probably it's got. So there's this module called forwardable, I think. So we cover this in just a minute, and then we can say has. What is it? Refactoring. Oh, I'm on it. So module forwardable. So if we look at this module. So module forwardable, we can define def delegators. And when we implement forwardable, so it says we can require forwardable. Is that what I typed in there? No, I did module forwardable. Require forwardable. And then if we have a records array, we can say extend forwardable, and then we can say def delegator. We extend forwardable, and we can say def delegator. And what we want to delegate it to is our parts. We want to delegate parts. I think. Yep. What's this record number? So the forwardable module provides delegation of specified methods to a designated object. So you have a class record collection which contains an array of records. You could provide the lookup method for a record number, which simply calls array on the records array like this. All right. So we need to say everything that we want to delegate. Okay, I might be getting ahead of myself here, but if we want to say that we want size, then it's gonna, if this class receives the size method, it's just gonna pass it to our array of parts. And then we get 3 back. But I think I'm getting a bit ahead of myself here. So let's move on. So yeah, I don't think they're missing some code here because we still don't say where this is coming from. But so in a perfect object-oriented language, this solution would be exactly correct. So perhaps that's why it's not working the way we expect it to. So unfortunately, the Ruby language has not quite achieved perfection, and this design contains a hidden flaw. So this next example, it illustrates the flaw. When parts subclasses array, it inherits all of array's behavior. This behavior includes methods like plus, which adds 2 arrays together and returns a third. So this appears to work. So here, if we have combo parts and we say mountain bike.parts plus road bike.parts, and we add them together, it appears to work. We get 7 back. But combo parts is an array. It is not a parts object. So when we ask it for its spares, it errors out. No method error. Undefined method spares for array. So that's the root cause of the problem is revealed by lines 15 through 17 right there. We just covered. So although the objects that got plus together were instances of parts, the object that plus returned was an instance of array, and array does not understand spares. So it turns out that there are many methods in array that return new arrays, and unfortunately these methods return new instances of the array class, not new instances of your subclass. So so that seems to work, but it doesn't quite work the way you would expect it to. So there's three. So it says you've seen three different implementations of parts. The first answers only the spares and parts message. It does not act like an array. It merely contains one. The second parts implementation adds size, a minor improvement that just returns the size of its internal array. And the most recent parts implementation subclasses array and therefore gives the appearance of fully behaving like an array, but as the example above shows, an instance of parts still displays unexpected behavior. So it has become clear that there is no perfect solution. It's therefore time to make a difficult decision. So even though it cannot respond to size, the original parts implementation may be good enough, right? Maybe we don't need it to respond to size. So then if so, you can accept its lack of array-like behavior and revert to that version, right? So we can just say, we'll just revert to that original version here. Get rid of the, so this is the original version. And this may be good enough, right? Maybe. And so you should never like write more code than you really need to in that moment, right? So it might be good enough. If so, you can accept its lack of array-like behavior. But if you need size and size alone, it may be best just to add that size method, right? The def size and say parts.size. And then, but you might get, if you can tolerate the possibility of confusing errors or, with absolute certainty that you'll never encounter them, it might make sense to use subclass array and walk away quietly. There's a better solution, and that's what we're going to talk about next. So somewhere in the middle ground between complexity and usability lies the following solution. So here, the parts class. So here's where we require forwardable. We can extend forwardable. And then there's def delegators. So let's take a look at it. So def delegators here. I went too far. So it's an instance of def instance. It's an alias for def instance delegators. So if we look at def instance delegators, it's just a shortcut for defining multiple delegator methods. So what it does is, so if we've got an array here, we say, okay, we want to delegate size, the append, or the shovel method, and the map to our array at records, or in our case, at parts. And what that does is that it just calls a def delegator method and says, okay, at parts size, at parts shovel, at parts map. So every time that our parts gets the size message, it's going to send that to our parts message. That's neat. And then so the parts class, blah, blah, blah. So the parts class now, the parts class below delegates size and each to its at parts array. And it includes the enumerable to get common traversal and searching methods. So this version of parts does not have all of the behavior of array, but at least everything that it claims to do actually works. But if we take a look at the Ruby documentation for array, we can see here that, okay, it's got its parent object is object. It's got all these methods here that are specific to array. And then it also has an included module, which is enumerable. And then so it also has all these methods here. And modules, as we learned in chapter 7, modules are a way to share code between objects that are not related at all. So we can take a module and get all of its code for free, all of its behavior for free. What enumerable gives us is that it gives us most of what array does. We can, so there's a select method here, which we are using. We got the, we can ask for its max, reject, reduce. We can grep it, we can map it. We can get the first object. We can ask for the first, and say we got all the each, the count, collect, chunk, all any. So we get a lot of behavior if we can just include this enumerable module. And that's what it does. So we include the enumerable module, and we get all this behavior for free. So what do we have to do to include this enumerable module? So the enumerable makes and provides collection classes with several traversal and searching methods, and with the ability to sort. So the class must provide a method each. And that's all we have to do, is we just have to provide a method each, and we get all this behavior for free, which yields successive methods of the collection. And then if enumerable max, min, or sort is used, the objects in the collection must also implement a meaningful spaceship operator. That's just a way to define how one is greater or less than the other, as these methods rely on an ordering between members of the collection. So the good thing is that we have an array already that understands each. So if we just forward that method to our array, then we don't have to implement a separate each method. So that is what it's doing. It includes the enumerable, and then it says, well, if we get the method each, just forward it to array, because this array object already has the method each implemented. So we don't have to implement each in our class, which we could if we wanted to. So let's do this. Let's write it up. Does that make sense, or is there anything?
Yeah, makes sense.
Cool. So let's do it slowly though, if that's okay.
Huh.
Let's take it one step at a time. So let's include our module enumerable in our parts object. And so when we include a class, that gives us access to all of its methods, right? Do you remember the difference between include and extend?
Yeah, so include gives us all the parts,
Mm-hmm.
all the classes of that class, all the methods of that class.
Mm-hmm. And what about extend? What does that do? It's a bit difficult to explain. So
Can I try?
yeah, go for it.
Yeah, so I think when you include a module, its methods becomes the instance method of, as in, uh, the methods in that module becomes the instance method in the included class.
Mm-hmm.
And for extending the methods in that module becomes class methods
Mm-hmm.
in that particular class.
I think you are correct, sir. So here's a Rails tip. So include versus extend in Ruby. So we know the difference between an instance method and a class method, I hope. So an instance method is just a method on an object, and a class method is a method for that class. So let's cover the difference between include and extend in regards to modules. Include is for adding methods to an instance of a class, which is exactly what Gideon said. And then extend is for adding class methods. And it's pretty much as simple as that. So when we use include, we get methods for the instance. And when we use extend, we get methods for the class. So why do we care about that? So here's an example. If you've got a module foo, it's got a method foo that puts hey yo. If you've got a class bar that includes foo, we can say bar.new.foo and it works. But if we say bar.foo, we get undefined method. If you've got a class that extends foo, then we can say bar.foo. But if we use bar.new.foo, we get an error. So that's basically what it is. Includes gives us methods for the object, and extend gives us methods for the class. So when we include enumerable, where's our code? So when we include enumerable, we can ask the object for its size. We can't ask the class for its size. Well, actually, enumerable doesn't have a size method, but it does have a first method, so let's use that. We can ask the object for its first. We can ask parts for first, but we can't ask the class for its size or first method. So it makes sense to include enumerable here because we want to be asking the object for its size or for its first part or its last part. When we extend forwardable, we get method def delegators on the class. We don't want to ask, we don't want to assign, we're not going to use this method on the instances of the objects, but we can use it on the class. All right, so we're going to say this class, for all the objects that are ever made, is going to do this. So it makes sense to extend forwardable and then module there, and then when we use enumerable, it makes sense to include it. So let's include enumerable in our parts class. And then I don't know. Do you just hello? Hey Seth, do you want to type or should I go ahead and type this up?
Yeah, go ahead.
Okay. So if we include enumerable, here, and then we try to ask the bicycle for its. Let's see, what's on enumerable first part. So if we try to ask bicycle p road bike dot parts dot first, does anyone know what's going to happen? So if we look at enumerable, it does have a first method, but in order to get all these methods, we do need to, so this class must provide a method each. So if we run this code, it's going to error out. All right, so we get an error, and it's saying undefined method. Oops, I got to get rid of this first. Let's try that again. Okay, and it errors out undefined method each. So it needs an each method. So let's give it an each method. So if we go to parts, and then we say def each, and when we get the each, we're just going to say, I think we can say, so array, so at parts is our array, and that understands each. So we're just going to say each there, and then n. And that didn't seem
Weird.
It didn't seem to work. I got this to work last week. And I was hoping I still remembered what I did last week, but I think my brain is too old to remember stuff for a week. So how do we define each method on class, on instance? So include enumerable def each Ruby. So let's look at this real quick. So I've got to have and block. That's right. I think there's a quicker answer somewhere here. How do I use the enumerable mixin? So here, yeah, so I need to have the and block. And then if members is an array, then I do this. It says, or I can do this at members.each and block. Well, let's see if this works. So that time, so it works now. So now when I ask for when I ask for first, it just returns the first part right there. So this is how you would define the each method. And if we were to look up the Ruby code for each, it'd probably say, oh, you'd probably derive this. I'm not that well versed in Ruby, so this is kind of confusing to me, but it does work. Basically, each needs an and block because you can always pass in like we could say like roadbike.parts.each, and then we can pass in a block saying for each part, just select the parts that need a spare, right? And then if we were to print this, we'll get our, let's see. Wrong number of arguments given, 0. All right, well, it should work. But yeah, so this is how we would define the each, but this is kind of hard work, right? You saw how hard that was to define this. The array already is an array, and we can just say that, well, since we already have an array that understands, that already has each implemented on it, then what we can do is we can require the forwardable module. And when we require the forwardable module, all it says is that we just need to implement one of these, we got to just implement the delegator, right? Def delegator, or we can use a shortcut method to implement multiple delegators. So what we can say is, okay, for the forwardable module, we know we want to put this on our class. So we're going to extend it. It's fine, I can do it here. So we're going to extend forwardable. And then what we can say is def delegators. And what we're going to say is, so we're going to give it our parts. Yeah, parts. And then we say delegate the size. Let's just do delegate each. All right, so now when we get the each method, it's going to say delegate it to the at parts array. And at parts has each implemented in it, so it'll work. So if we ask for, I got to put this below there probably.
I think parts should be a symbol. Yeah.
Yeah.
Make it a symbol.
Oh, a symbol. Oh,
Yeah.
Thank you. You're absolutely right. And that is in the documentation too, to have it as a symbol. So you can even go like this and put the @ sign there. If you don't have the attribute reader, you could put the @ sign and it still works. It just needs to be a symbol to convert it. So, so now we don't have to implement the each method ourselves. We just say, hey, just forward that each method to the parts array and let the array class take care of it because it understands each. And now if we want to add size, well, array understands size too, right? So we can ask, so we can just say, hey, forward size to that array class, and we can get, now we can say road bike dot parts dot size, and we get a 3 back, and it works. And if we say, okay, well, let's take our road bike dot parts dot and let's add that to our mountain. Let's see, do we have mountain bike here? We got a road bike. I don't have a mountain bike. Let's create one real quick. So mountain. This will take a mountain tire, I believe. We got a mountain tire, and it doesn't take tape. So if we say road bike dot parts plus mountain bike dot parts, what happens when we run this? It says undefined method plus for parts. So now we get a clear error when we try to add it, and we get a clear error. It's undefined. And if we absolutely want that, we can just say, well, we want parts to understand the plus method, and we have an array that understands the plus method, so we can just add that to our def delegators, and then when we run it, that doesn't work. No implicit conversion of parts into array, type error. No. Yeah. Plus does not work. I did not try this last week. But at least we get an error showing that it doesn't work. And with a little bit of, we could work on this to make it work too. All right. Let's see what the book has to say. So yeah, so it has become clear. So somewhere in the middle ground between complexity and usability lies the following solution. The parts class will delegate size and each to its at parts array, and includes enumerable to get common traversal and searching methods. So this version of parts does not have all of the behavior of array, but at least everything that it claims to do actually works. And then sending plus to an instance of this parts results in a no method error, which we saw. However, because parts now responds to size, each, and all of enumerable, and obligingly raises errors when you mistakenly treat it like an actual array, this code may be good enough. So the following example shows that spares and parts can now both respond to size. So you again have a workable version of bicycle parts and part classes. So then it's time to reevaluate the design. So yeah, so this has been about an hour now. I know I've talked on a lot, and so we saw how to include enumerable, and then we extended forwardable to easily implement the enumerable class. We see that it's not quite easy to add on more methods that array has, such as plus. I think seems like we should be able to get it to work, but it might take a little extra work, obviously. It's not as simple as adding it to the def delegators. So it says no implicit conversion of parts into array, and here it's capital, so that means it's a parts. It's talking about the parts object. It's trying to convert the parts object into an array. Because remember, when we use the plus method, it actually returns a new array. And so if we've got a parts object adding to a parts object, and it's trying to return a new array, it's saying, hey, I can't do that. Well, what we would like it to do is just return a new parts, right? A new parts array. So I'm sure we could probably get that to work with a little extra work, but little extra code. But again, at least we get an error saying that, hey, I can't do this, instead of when we did inherit from array, it actually went and did it, but there were like hidden bugs, or maybe you might call them features, hidden features in there that might have surprised us. The results might have surprised us, but at least now it explicitly says that, hey, I can't do this, and this is why I can't do this. But we do get all of the enumerable methods, and if we implement the spaceship operator, so let's, we could I think it's pretty easy to implement a spaceship operator. All you got to do is say def spaceship, and then you say then you need like the other object, right? And then what you're going to say is let's say we want to sort it by name. So we'd say name is less than, equal to, greater than other object dot name. And then we should get all the sort options too. So if we say print road bike dot parts and say sort, let's see if this works. And define, oh, I still got the plus in there. Whoops. Comparison of part with part filled, argument error. Okay, I think I might be missing something. I thought I only needed to provide one argument. Have to look into that more. I'll just post it into the chat channel. Does somebody know what I'm missing? Or let's see. Def. Yeah, spaceship. Other object.
Do you have name available in parts?
Nice. Oh.
Yeah.
Thank you very much. So that actually needs to go onto the part object itself. So yeah, so what we want to sort is a part, and so we're going to implement the spaceship operator on part. That way it can compare the parts objects to. So now when we run it, all right, it works. So we get chain, and then we get another part, which tape color is the name, and then we get another part that has the name of tire size, and that is sorted by name. So now we get all the sort methods and everything from enumerable as well. So by defining this object, we get everything that enumerable can give us. So our part class is almost like an array. There's still some array things that it can't do, but we could, implement those little by little if we wanted to. And at least when it doesn't do something, it actually tells us that, hey, it can't do that. So yeah, so that's the end for today. Next week, we'll definitely finish up this chapter. And next week is pretty cool. The rest of this chapter is pretty cool too. Where are you guys? So we'll be talking about manufacturing parts. So right here right now we got a lot of our code. I guess our code when we create a new bicycle and we got to create these parts and our part objects, it might not be really dry. If this was a big application, we might end up seeing code in various places that are the same code. So next week we create a factory class to create bicycles for us, to create parts for us for the bicycles. So yeah, so next week we'll create a factory class and wrap up the chapter. So sound good? And I believe also if we remove this parts from select, it should still work now the way we got it set up, and everything still works. And it's a bit tricky to see that, but yeah, interesting.
Yeah, that's weird, the way it works.
Yeah. So yeah, I spent a couple hours playing with this last week, and I had a good understanding of it before I was about to put the mob on, and then I realized I started the mob an hour late. So I had a pretty good understanding of why this was working last week. But go ahead and play around with this code. And try to figure out why that works like that, and explain it to me next week if you want. I'd be happy to listen to someone else's explanation, because that'll help me remember it, and it'll help you maybe remember it too. So do you want me to? I think I can push this up somewhere. I've got to get going. Let's see, what do we got? Okay, so I need to change directory to pooter. What if I just do git add? I think I've got, oops. Yeah, so I'm just going to push this up. So git commit dash ch, lots of stuff. I'll just say big commit work. I'll just git push this origin master. Oh no. That's not cool. So I gotta get back to this. Okay, so let's do this. So git checkout -b, and we'll check out update. Actually, let's get, and then what we can do is git checkout master, and then we'll do git reset hard. I think 2. Then if I do git log, now I can git pull origin master, and git checkout update, git rebase master, git checkout master, git merge update, and now I can git push origin master. All right. So this is all here, and if you want to play around with that code, feel free, and let me know next week what you figure out. So I will be more than happy to listen to someone else. Sound good?
Yeah.
Yeah.
Awesome. Thanks for joining. Sorry, I was kind of a little bit flustered there for a little while, but hopefully it was good.
Yeah, it was good.
Yeah, it was.
Cool. Right on. Have a good night. I'll see you next time.
Okay, thanks, Nick.
Thank you.
Okay, thank you.
See ya.
Bye.